Hello students, this video lesson is about set operations and compound inequalities. In set operations, we use different symbols, like the symbol backwards, or kind of like an E, which represents the word element. We also use the symbol of empty set, which is two braces right next to each other, or possibly a circle with a line through it. Those are all set operation symbols. Another set operation symbol is a U, which represents the word union. The U, a union, means anything from a set, and if there's a union of two sets, it's everything in both sets consists of the union of those two sets. So down below here, I have set A, and I have set B. And I'm trying to find or determine the union of those two sets. What would be inside the union of those two sets? Well, if set A contains the numbers 5, 10, 15, 20, and 25, and set B contains the numbers 1, 5, 9, 13, 17, 21, 25, the union of those two sets is everything in both. So when you see the U, you're gonna include everything in both sets. So all the numbers in set A are going to be 5, 10, 15, 20, 25. But since the union contains both set A and set B, the set of the union would include everything from both. So I'm going to have to add the 1, and I'm going to have to add a 9, and I'm going to have to add a 13, and I'm going to have to add a 17, and I'm going to have to add a 21 to my set, to my items within the set. So the union of A and B consists of all of those numbers. Set notation is just a way of labeling information. Here's another example. I have set C, which contains the letters A, B, C, D. And I have the set D, which contains the letters C, D, E, F. And now I want to determine what's the union of those two sets. So everything in both. So I'm going to have B, or A, B, C, D, E, and F. All of those are going to be within the union. And, you know, set notation can be used in mathematics as well as in other fields. Now, another symbol within set operations is the intersection. The symbol is an upside down U. Some textbooks will even use a capital I. But in the textbook that we use, we have the upside down U, which represents intersection, where they overlap. So if we're trying to find the intersection of two sets, we're trying to find what do these two sets have in common. So the set of the intersection of two sets is what they have in common. Notice that set A and set B both have a 5, and they both have a 25. Those are the only two things that they have in common. So those are the only two items that are going to be inside the set for the intersection of these two sets. So again, a set may be numbers, maybe letters, maybe words. Anything can become a set. On my right-hand side here, I have two sets, set C and set D. And I'm looking for the union, or the intersection, what they both have in common. Well, let's see. They both have a D in common. And that is the only thing they have in common. Oh, they have a C, don't they? They have a C and a D. They have a C and a D, a C. infinity. So I need to add that to my set. Okay, so that is set of operations, or set operations. Now, in mathematics, we utilize inequalities. An inequality is a mathematical statement that contains an inequality sign. And an inequality sign is simply greater than or equal to, less than, or less than or equal to. And inequalities can be, the solution to an inequality can be represented on a number line. So down here below, I have x is greater than or equal to 5. So that equal to, that line underneath the inequality represents that this x can either be bigger or it also can be equivalent to the 5. If the line was not there, then that means it has to be bigger. The bigger, on the inequality sign, the bigger end is always towards the bigger item. 10 is greater than 1. So when I come down here to read my inequality, x is going to have to be bigger or greater than or equal to 5. So it can be equivalent to 5, so I'm going to use a bracket on my 5, right at 5, because this bracket represents that it can be equal to 5, but it can also be everything beyond or anything to the right of 5. As opposed to if I have x is less than or equal to -4, we'll say that's 0, and we'll just put 1, 2, 3, 4. So now it's going to be going in the other direction because x is everything smaller than -4 or equal to -4. So notice that if the arrow is as long as the variable is on the left, wherever the inequality sign is pointing, that is how the graph is going to go. But again, the variable has to be on the left-hand side. So those are inequalities. Now, inequalities can be represented in interval notation. We've got this right here, x greater than or equal to 5, and x is less than or equal to -4. That's one way of stating the solution. But if we want to utilize interval notation, it's going to look like almost identically to the number line. I'm going to start with a bracket, and then my solution starts at 5, but then it continues on and on and on to the right, and it never stops. So we have a symbol that represents infinity, which is a sideways 8. And since infinity can never end, we use a parenthesis. Parenthesis means it's approaching. Now over here on x is less than or equal to -4, we always write our solution from smallest to largest. And since it's going to the left, that means it's going to negative infinity, which never stops. So it's a parenthesis, negative infinity, and it's going up to including -4. So we have to put comma -4 with a bracket, because bracket means includes. Parenthesis means it's approaching, bracket means it includes. Now, when we have an inequality and we're solving an inequality, we're doing the same thing as if it was a equation. We're isolating the variable. One of the things within inequalities, if I am dividing by a negative number, that is going to require for the inequality sign to flip to its opposite. So whenever you divide to both sides of an inequality, the inequality symbol must flip. A -2 divided by a -2 is going to be a +1. But now I no longer have a greater than sign, I'm going to have a less than sign. 4 divided by -2 is going to be -2. this rule is necessary in order to keep the statement true. If it didn't flip, it just wouldn't be equivalent. So now for my graph below, I have x is everything smaller or to the left. The arrow is pointing to the left, so that's how my number line arrow is going to be going. So I'm starting at -2, but I don't include it because there's no line underneath my inequality sign. And then it's going to the left. So the way I write my interval notation is parenthesis, -infinity, comma, -2. And this time I have to use a parenthesis because it's never getting to -2. It's getting closer and closer and closer, but never actually includes -2. Whereas this number on over here, this inequality on the right-hand side, I'm going to divide both sides by a -1. Which is going to create x, I have to flip the sign, is greater than, sometimes my stylus just does not want to work. So x is greater than or equal to a +5, because a negative divided by a negative is positive. Now my arrow is pointing to the right, so that's how my arrow on my number line is going to be drawn. I start at +5, and this time I include it, so I put a bracket. And it's going further and further to the right and never stops. So therefore, my interval notation is bracket +5, comma, infinity, parentheses. Because again, infinity never stops. So now here I have a little bit more complicated inequality that I need to solve. I need to get the x all by itself. And again, we're going to do this as if it was an equation. We're going to use the same properties. We're going to minus our 9 first. So then I have 2x is less than or equal to -4. And then to undo multiplication, we're going to divide the coefficient, the number in front, and I end up with x is less than or equal to, less than or equal to -2. X is less than or equal to, stylus is not picking up. Let's see if I can put my screen up. Less than or equal to -2. Okay, so now we're going to graph that on our number line. Because it has a line underneath the inequality sign, I'm going to have a bracket. So I'm going to come over here, I'm going to start at -2, and my arrow is pointing to the left, so it's going to go to the left. So all the numbers to the left of -2 will make this inequality true. So for me to write this in interval notation, I'm going to say parentheses, negative infinity, comma, -2, bracket. So what's that saying is if I pick a number that is within that interval, this interval right down here, so let's say -4. -4 is being shaded on the number line. So if I was to plug in -4, 2 times -4 plus 9, it's going to be less than or equal to 5. Well, 2 times negative 4 is negative 8, and negative 8 plus 9 is going to be a 1. And 1 is indeed smaller than 5. So negative 4 does work in that inequality. So the solution to an inequality is a value that will make that inequality be true. Now over here on my right, I'm going to solve this inequality by isolating my x. The first thing I'm going to do is subtract my 7. So now I have a negative 3x is greater than or equal to negative 12. Now to undo multiplication, I'm going to divide. And because that coefficient is a negative number, I'm going to have to flip the inequality sign. So now I have x is less than or equal to a positive 4, because negative 12 divided by negative 3 is a positive 4. And then for me to put this on my number line, I have a line underneath my inequality, so it's going to be a bracket. And I'm starting at 4, and my arrow is pointing to the left, so it's going to go to the left. So I have my bracket at 4, and it's going to the left. So my interval notation is going to be parentheses, negative infinity, up to positive 4, and includes it. Now, on this wording right here, I just reinforce the fact that when you use a less than or greater than sign, you use parentheses, as opposed to if you use less than or equal to, you're going to use brackets. And it talks a little bit about the infinity and so forth. So let's see, right here, infinity to infinity. What does that mean? That means everything on the number line is going to work. Let's say if I had a number line that was completely darkened, everything happened to work. The interval notation for that would be negative infinity, comma, infinity. And that's considered interval notation. We also have what's called set builders notation. And if I'm wanting to state everything on a number line works, sometimes we just use the capital R to represent real numbers, all real numbers. And we talked about that the very first day of class. Counting numbers, whole numbers, integers, rational numbers, irrational, those are all real numbers. And the entire number line consists of real numbers. So let's kind of delve into some of our compound inequalities, and we might get to use some of those symbols. So far, what I've been working with was just one inequality that I solved, and I graphed it. Now I've got two inequalities. I've got one on the right, and I have, it says an and, so I have another one to the right, or one on the left and one on the right of the word and. Now remember, and is the same thing as intersection. The word and the upside down U both mean intersection. So I'm trying to find out where these two separate inequalities overlap. What do they have in common? So let's see, I'm going to have to solve each of them. First of all, x is greater than 4. That's pretty simple. I'm not going to put it on my final number line. I'm just going to sketch that above. So x is greater than 4. That would be pretty much like that. Now my second inequality, 3x plus 6 is less than 12. I have to solve that. So I'm going to subtract my 6. And I'm going to get 3x is greater than, and I'm subtracting there. My stylus isn't working that great. 3x is greater than 6, and I'm going to divide by 3. So I have x is greater than 2. So now 2 is right over here, and it's a parenthesis also, and it's going that direction. Also, they're both going in the same direction. But the word and is saying, where do these two lines cross? Where do they overlap? Well, they overlap pretty much everywhere past 4. So the intersection x is greater than 4 and x is greater than 2, the intersection of those two inequalities is going to be parentheses 4, comma, infinity, parentheses. Because at 4 and everything to the right, those two lines would be right on top of each other. So that's the point that both of those inequalities share. That's the intersection of them. So compound inequalities just mean that you have more than one inequality that you're comparing. And when you have the word and, you're determining where they overlap. Or if you have the symbol of a upside down U, you're asking yourself, where do these things overlap? Okay, so let's move down so we can solve these. So I have to isolate the variable on each inequality. So I'm going to minus my 2 on both sides. And I have 3x is less than 3. And then I'm going to divide by my 3. So for my first inequality, I have x is less than 1. And then for my second inequality, I'm going to add a 4 on both sides. And I have x is less than negative 4. Okay, so now I'm going to try to determine where these two things overlap. So let's see, x is less than 1, so, and it's a parenthesis because there's no line, and x is greater than negative 4, so they're going towards each other. So the only place that they're going to overlap is the area in between. So for the inequalities, or the compound inequality, x is less than 1 and x is greater than negative 4, the numbers that are going to be within that set, within that solution, is starting but not including negative 4, comma, all the way through to 1, but not including 1. It's just approaching 1. So the parenthesis negative 4, comma, 1 parenthesis looks like an ordered pair. But in this context, it's an interval on a number line. So sometimes in mathematics, you have to look at the context of what is being used in the situation to determine what it really is representing. Okay, so let's go ahead and do this other one over here. So I'm going to subtract my 9 from both sides. So minus 9 minus 9. So I have negative 2x is less than negative 4. Now I'm going to divide both sides by negative 4. When you divide by a negative number across an inequality, we're going to have to flip that inequality symbol. So negative 2 divided by negative 2 becomes a positive 1. But now I no longer have a less than, I have a greater than. Negative 4 divided by negative 2 is a positive 2. So my first inequality is x is greater than 2. And now I want to find the intersection. And over here, I'm just going to add 7 to both sides. So I have x is greater than -1. So I'm trying to determine what numbers are greater than 2 and at the same time greater than -1. So let's see, 2 is right here, and they're both going to be parentheses, and positive or -1 is over here. So where they overlap is going to start at +2, but doesn't include it, and everything to the right. Because when you have the symbol an upside down U, it's intersection, where they overlap. So now I want to write this solution in interval notation. Well, it starts at 2, so parentheses 2, doesn't include 2 because there's no line underneath it, and it goes on and on and on forever. Now, sometimes we use the word and for intersection. So go ahead and give these two a try on your own. Stop the tape and go ahead and give them a try. And once you've finished, go ahead and restart the video and check your work. So how did you do? The first thing you'd want to do is you want to isolate the variable, so you're going to add 5 to both sides, which would give me 2x is less than or equal to 12. And then I'm going to divide both sides by 2. So then I'm going to get x is less than or equal to 6. So that's my first inequality. On the right-hand side, I'm going to subtract 8 from both sides. And I'm going to end up with 4x is greater than -12. And then you would have divided both sides by 4, and you'd get x is greater than -3. Now the left-hand inequality has a line underneath it, so it's going to have a bracket. This is an and sign. Okay, so x is everything less than or equal to 6, and that's going that direction. And my second inequality is x is greater than -3, but does not include it, so that's going to be a parentheses. And because they're going towards each other, only the numbers in between will work in both equations. That's where what numbers they share. So my interval notation would be parentheses, -3, comma, 6, bracket. Now the second inequality, compound inequality that we have over here, we're going to subtract our 16 from both sides. And we're going to get 3x is less than or equal to -21. And then we're going to divide both sides by 3, and we're going to get x is less than or equal to -7. Because a -21 divided by a +3 is a -7. I didn't have to flip anything because 3 was not negative. It's only when the item in front of the variable is negative that you're dividing away, that's what causes you to flip. Now on the right-hand side, I'm going to subtract 4 from both sides. So I'm going to get 7x is greater than 14. And then I'm going to divide both sides by 7, and I'm going to get x is greater than 2. And I'm looking for the intersection. What do these two things have in common? Well, the inequality on the left has a line under inequality sign, so it's going to be a bracket, and it's at -7. So that's going to include -7. And it's going to the left, isn't it? It's going this direction, isn't it? And this x is greater than 2 is going in the other direction. So do they overlap anywhere? They don't, do they? They have no solution. They do not overlap anywhere, so you simply say no solution. There is no intersection of these two inequalities. And you don't put anything on the final number line because there's nothing that they share. Okay, let's move on. Now these inequalities have the word or they have the U symbol, which means everything in both, just like the set notation. And means what they have in common, or means what everything in both. Like you could pick anything from this group or this group. So I still have to isolate each inequality separately. This x is greater than 4 is already done for me. But this second one, I would have to subtract my 6. So that's going to give me a 3x is greater than 6 because 12 minus 6 is 6. And then I'm going to divide by 3. So x is going to be greater than 2 because 6 divided by 3 is going to be 2. So now I have an inequality that x is greater than 4 or either the word or the u, which means union, or x is greater than 2. Notice they're both going in the same direction. I'm saying I could pick anything that's bigger than 2, or I could pick anything that's bigger than 4. Well, what that is meaning that everything bigger than 2 would include what's bigger than 4. So my options that I can pick from start at 2, so parentheses 2, and I can pick any number bigger than 2, so infinity. So I've written my solution on the number line, and I've stated the solution by using interval notation. So let's do some more. These are compound inequalities, but this time they use the word or they use the symbol U. So I'm going to have to isolate my variable. So I'm going to subtract my 1. That's going to give me a 2x is greater than or equal to 6. Then I'm going to divide by 2. So that's going to give me x. So that's going to give me x is greater than or equal to 3. And then I have the word or union. So on my second inequality, I'm going to subtract 3 from both sides. And I'm going to get 4x is less than -16. Because -13 minus 3 would just give me more negatives, so -16. And then I'm going to divide by my 4. 4 is positive, so I don't have to flip anything. And I end up with x is less than -4. So since this is a u, it's everything in both. I could pick a number that's equal to 3 and bigger than 3, or I could pick a number that is less than -4 but doesn't include -4. So this time I can put both of them. Notice that I'm jumping over a area. I always think of the u often means that there's a valley in between what's included. Not all the time, because sometimes they're going in the same direction. But if they're going in different directions, that valley, I kind of like to mentally think as the representation of the U. So when I'm writing my integral notation, everything to the left, negative 10, or actually, sorry, that's going to be negative infinity, isn't it? Negative infinity up to negative 4. And I can't include negative 4 because there's no line underneath it. But now I'm jumping over like a valley. So that's where I put my union symbol. And then I pick up at 3, including 3, and I go on and on and on forever. So I close it with the parentheses because infinity never stops. Let's do another one. I'm going to isolate my variable. I'm going to minus my 3. So I'm going to get 2x is less than 6. And then I'm going to divide my 2. So x is less than 3. And then on the right, I'm going to subtract 5 from both sides. So I get negative 2x is less than or equal to negative 12. Now I will be dividing by a negative number. And when I divide by a negative number, I'm going to have to flip my inequality sign. So now I'm going to have x is greater than or equal to a positive 6, because a negative over a negative is positive. And I'm trying to determine where they, oh, this is a union, everything in both. Everything in both is acceptable. There we go. Okay, so x can be anything less than 3. So 3 is right here. Let's go in that direction. Or x could be everything bigger or equal to 6. So yeah, they're going in different directions. So this is the 3, and it's going this way. And I am going to jump over some area because 6 picks up over here, and it's going to be a bracket because it has a line underneath it. That line right there. So now when I write my integral notation, I'm going to say negative infinity up to 3, then union, I'm jumping over, I'm picking back up at 6, and I can continue on until infinity. So go ahead and stop the video and give these two a try on your own. Isolate the variable and then determine what the solution is. So how did you do? We're going to, in order to isolate the variable on the first one, we're going to have to subtract 1 from both sides. And then we're going to have to divide by 2. So we have x is less than or equal to negative 4. And then for the one on the right, I'm going to have to subtract 3. And then I'm going to divide by a negative number. So I'm going to flip that sign. And I'm going to have x is greater than a positive 3. Because negative 15 divided by a negative 5 is going to give me a positive 3. Now I need to go down and put those on my number line. I have x is everything less than negative 4, so that's to the left of negative 4. and it includes it. And over here on the right, I have x is everything bigger than 3, but it does not include it. So my interval notation is going to be negative infinity, comma, -4 bracket, union, because I'm jumping over, parentheses, 3, comma, infinity. Now the second one over here, we're going to isolate the variable. We're going to divide both sides by 2. X is less than 4. And then on the other one, I'm going to subtract 5 first. So I have -5x is less than or equal to 5, because 10 minus 5 is 5. Now I'm going to divide by a negative number, so I have to flip my sign. So I'm going to have x is greater than or equal to a -1, because positive divided by negative is negative. So now let's see, I have x is less than 4. So here's 4, x is less than 4. And I have x is greater than or equal to -1. And this is a union, so it's everything in both. So that means my entire number line is going to be choices. Every single number will work in one of those because union means one or the other. So this is a case that the entire number line is the solution. So my interval notation is negative infinity, comma, infinity. And this concludes the first video lesson.